What is an algorithm? With real examples. What does algorithm mean? An algorithm is a step-by-step set of instructions used to solve a problem or complete a task. In simple words, algorithm equals a clear list of steps to do something. So, algorithm tells the computer what to do and in what order. Example idea. Making tea has steps means that is an algorithm. It means, an algorithm is a sequence of steps, a method to solve a problem, a plan before writing code, a logical process, independent of any programming language. So, algorithm equals problem means steps means solution. Why it matters. Without algorithms, crossmark no clear logic. Crossmark programs become messy. Crossmark hard to debug. Crossmark hard to improve. Crossmark same problem solved differently each time. With algorithms, checkmark problems are broken into steps. Checkmark logic becomes clear. Checkmark code becomes easier to write. Checkmark errors are easier to find. Checkmark solutions are reusable. Real-life examples of algorithms. Think of algorithms like daily routines. Example 1. Brushing teeth. Take toothbrush. Put toothpaste. Brush teeth. Rinse mouth. That is an algorithm. Example 2. Cooking rice. Add water. Add rice. Boil. Drain water. Serve. Example 3. Traffic signal. If light is red means stop. If light is green means go. So, steps equals algorithm. Action equals result. How algorithms work. Step by step. Take input. Problem or data. Apply steps. Logic. Produce output. Solution. Flow. Input means steps means output. Types of problems algorithms solve. Algorithms can solve math problems, searching data, sorting numbers, making decisions, repeating tasks, checking conditions. So algorithms are used in games, apps, websites, machines, AI systems. Example scenario. Real life. ATM withdrawal example. Algorithm. Insert card. Enter PIN. Check balance. Ask amount. Dispense cash. Print receipt. Here, each step is clear. Order matters. Skipping a step breaks the process. This makes the system checkmark reliable, checkmark safe, checkmark logical. Common beginner mistakes. Beginners often jump directly to coding, skip planning steps, write unclear logic, forget edge cases, mix logic with syntax. These happen because algorithm is not designed first. Good practices for algorithms. Checkmark write steps clearly. Checkmark keep steps simple. Checkmark follow correct order. Checkmark handle special cases. Checkmark test with examples. Bad. Crossmark vague steps. Crossmark missing conditions. Crossmark too many actions in one step. Good. Checkmark one action per step. Checkmark clear conditions. Checkmark simple language. Real life analogy. Algorithm is like a recipe scroll. Recipe has ingredients. Input has steps. Process has dish. Output. Same with algorithm. Input equals data. Steps equals logic. Output equals solution. Important point. An algorithm is not code. Is logic behind code. Can be written in plain English. Can be drawn as flowchart. Can be implemented in any language. Without algorithm, crossmark code becomes trial and error. Crossmark bugs increase. Crossmark logic becomes unclear. Simple definition. Algorithm equals a step-by-step method to solve a problem. Summary. Algorithms. Checkmark break problems into steps. Checkmark make logic clear. Checkmark help write better code. Checkmark are used everywhere. Checkmark are the heart of programming. Without algorithms, crossmark no structure. Crossmark no logic. Crossmark no reliable programs. With algorithms, Checkmark programs become logical. Checkmark solutions become clear. Checkmark software becomes powerful.